After completing device configuration setups, the next stop is the sensor screen. The sensors screen is where you configure the various types of sensors that will be used in the test, along with the properties and parameters of each sensor. Let's take a quick look at the sensor screen and then follow with a simple example of sensor configuration. Beginning at the far left, the sensors tree displays the 9 basic analog sensor types that TCS supports. These are voltage, acceleration, strain, digital, defined as either period or frequency sensors, thermocouple, other, which offers a choice of sensitivity or polynomial configurations, displacement, load, and pressure. Selecting the basic sensor type is the first step in defining and configuring a sensor. A new sensor is created either by double-clicking on a selection in the sensor tree or by clicking on the F5 New Sensor button. If you simply double-click on a sensor, a default name is assigned to that sensor. If the New Sensor button is used, you must assign a name for the sensor. Using either method, once the sensor is created, the name cannot be changed. When a new sensor is created, the main area of the sensor window displays the available configuration parameters for that sensor type. The window is divided into 2 parts. The upper part of the window displays text fields that allow you to enter basic information about the new sensor, including manufacturer, model number, serial number, and calibration due date, as well as any descriptive information you may want to add. It also includes selectable values for engineering units and calibration thresholds. The lower part of the window contains the configuration parameters and options for the chosen sensor. This part of the window is divided into 3 basic sections that address the device hardware configuration, the sensitivity and offset, and the calibration. The options that appear here vary according to the type of sensor being configured. Any configuration option that is grayed out is not applicable to the chosen sensor and cannot be selected. We'll be returning to this part of the window later to cover some common sensor configurations. The upper part of the window has an Engineering Units drop-down, which allows you to select the unit of measure for the output data. By default, the engineering units displayed are the ones typically associated with the selected sensor type. For example, when a strain sensor is selected, the engineering units default to microstrain. In addition to the standard list of engineering units, you also have the option to specify custom units by clicking on the Custom Units checkbox and manually entering a new unit. To the right of the engineering unit selection is the calibration target threshold selection. Set to a factor default of 2%, the calibration target threshold sets the limit of acceptable calibration performance when the onboard calibration function is enabled. Towards the bottom of the window is the sensor table display, which provides a non-editable overview of all of the defined sensors for a given sensor type. Table entries are updated after completing each sensor configuration. At the bottom of the window, function keys provide alternative selection methods for some common functions. Using either the mouse or the function keys on the keyboard, you can disconnect from the current device, import or export sensors, add a new sensor to the list, delete a sensor, perform a physical calibration, issue a manual command to the connected device, switch to the in-vehicle display window, or get context-sensitive sensor help. Sensor import and export functions, physical calibrations, and the in-vehicle display will be covered in other tutorial videos. Now let's create a sensor configuration for measuring a 9-volt battery as a simple example. To make the measurement, we'll need to configure a voltage sensor. To begin, we click on the New Sensor button and assign a name. For this example, we forego the text fields in the upper part of the window and focus solely on the configuration parameters in the lower part. Note that for a voltage sensor, the input dividers are automatically enabled. This allows TCS to accept large input signals, and so we'll leave it enabled. For our battery example, the sensor output impedance value can remain at 0, and since the battery is not referenced to ground, the input connection type can be left set to differential. Finally, because we're measuring a voltage source, no excitation is required, and so we set the excitation to none. Moving to the next column, the default sensitivity value is already correct for our setup, and no offset adjustment is needed. With this, our simple voltage sensor configuration for a 9-volt battery is complete. To get assistance with the physical connection for this setup, click Sensor Help, and then click on the wiring diagram link. TCS displays the physical connection for a differential voltage input. Before we can make a measurement using this sensor, we need to assign the sensor to a channel. We do this by switching to the Tags and Channels screen and assigning the battery sensor to the desired channel, in this case channel 1. We'll give channel 1 a name, but leave all other settings to the default state. While we're here, however, let's disable all other channels by doing a group selection and unchecking the Channel Enabled checkbox. TCS will now monitor and display just channel 1, the channel of interest. Now switch to the Runtime tab and click Scan. TCS sends the voltage sensor configuration to the connected device and then begins to monitor channel 1. Since the battery voltage is a static unloaded signal and no other channels are displayed, the scrolling window shows a single solid line at 9.5 volts. If we now switch to the single pod monitor screen, we can view the measurement as a numerical value with 3-digit precision. This concludes the sensor configuration overview. You can find information on other types of sensor configurations in additional sensor videos, or continue the TCS Learning series by viewing the Tags and Channels video.